For as long as people have looked up at the sky, the sun suddenly vanishing has been, well, the ultimate celestial horror show. So today, we're going to take a journey from ancient temples, where an eclipse meant the gods were angry, all the way to modern-day expeditions, where people chase the moon's shadow across the globe just for a few minutes of pure cosmic awe. It's really a story about how we went from being terrified to being totally fascinated.
And that's the big question, isn't it? What flipped the switch? How did we go from thinking the world was ending to booking flights and hotels years in advance? The answer, is all about figuring out the incredible clockwork of our solar system, the delicate dance between the Earth, Moon, and Sun. But it's also a story about us, about how we learn to look up at the sky with curiosity instead of fear. Okay, so to really get why eclipses are so special, you first have to understand why they're so rare. It all starts with a kind of cosmic near miss, one that happens every single month, thanks to the incredibly precise yet just slightly imperfect mechanics of our little corner of the universe.
I mean, it's a totally fair question, right? Every month, the moon passes between us and the sun. That's called the new moon. You'd think that would mean its shadows should fall on us every time, and bam, eclipse. But it doesn't. And the reason why is actually pretty simple, but it changes everything.
This is it. This is the number that makes all the difference, just over 5 degrees. So imagine the Earth is zipping along a perfectly flat racetrack. That's our orbit. Now, the moon is on its own track, but its track is tilted by, you guessed it, just over 5 degrees. So most of the time, when the moon passes by, its shadow flies harmlessly over our heads or under our feet. It's a cosmic near miss every single month.
So for an eclipse to actually happen, everything has to line up perfectly. The moon's tilted path has to cross Earth's flat orbital plane at the exact same moment that the sun is also in that line. These crossing points are called the lunar nodes. This perfect three-body alignment has an amazing name, syzygy. A great word, right? It's all about that cosmic precision needed for the moon's shadow to finally hit its target, us.
And when that perfect syzygy finally happens, wow, the moon's shadow finally kisses the Earth. But it doesn't stick around. It races across the surface at thousands of kilometers an hour. And if you're lucky enough to be in its path, those last few moments before total darkness are an absolutely breathtaking, rapid-fire spectacle.
Okay, picture this. The world around you is changing by the second. Weird shimmering waves of light and dark, called shadow bands, start dancing across the ground. Then, as the very last sliver of the sun is about to vanish, the mountains and valleys on the moon's edge break up that sunlight into a string of brilliant pearls. We call them Bailey's beads. And then, just for a second, a single dazzling point of light is left, creating the famous diamond ring effect. It's like a jewel in the sky, and then it's gone. And then, totality. This is the moment. For just a few precious, fleeting minutes, the world is completely transformed. The sun you know is just gone, and in its place is this impossible black hole in the sky, surrounded by the ethereal, ghostly glow of the solar corona. This is the sun's outer atmosphere, this stunning halo of superheated gas that is millions of degrees hot and completely invisible any other time. It is, without a doubt, one of the most beautiful things you will ever see. During totality, the sky just puts on an incredible show. You might see this thin, pinkish ring around the edge of the moon. That's the chromosphere, part of the sun's lower atmosphere. You might even see these huge crimson loops of gas called solar prominences erupting from the surface. And because the sky gets so dark, bright planets like Venus and Jupiter just pop into view, all while you're standing in this weird 360-degree twilight that's glowing all around the horizon. It's unreal.
But imagine for a second you had no idea what was happening. What if you lived thousands of years ago, before science could explain any of this? For ancient cultures, the sun suddenly disappearing in the middle of the day wasn't a beautiful spectacle. It was a terrifying omen. It was a sign that something was deeply, cosmically wrong. So when faced with this terrifying event, cultures around the world basically went one of two ways. Some of them chose to fight back, to shout, bang drums, make as much noise as possible to try and scare away whatever monster was eating the sun. But others saw it as a sacred, powerful moment, a time to go inside, to be quiet, and to try and restore balance, both within themselves and in the world.
And you can see that incredible diversity right here. In ancient China, they believed a celestial dragon was eating the sun, so the logical thing to do was bang pots and drums to scare it off. For the Navajo or Diné people, an eclipse is a much more solemn event. It marks a cosmic death and rebirth, and it's a time to go indoors for quiet reflection. But my favorite might be from the Bottom Maliba people in Togo and Benin. They saw an eclipse as the sun and moon fighting, and they believed the only way to make peace in the heavens was for humans to set a good example and resolve all of their own fights here on Earth. Just wow.
Today, of course, we don't think a dragon is eating the sun. Our understanding has shifted from myth to, well, medicine. We know exactly what's happening up there, but we also know with 100% certainty that looking at it without the right protection can cause serious, permanent eye damage.
So what's actually going on inside your eye if you look? Well, the lens in your eye acts like a super powerful magnifying glass. It takes all that intense sunlight and focuses it onto one tiny spot on your retina. That intense light kicks off a nasty chemical reaction that creates a flood of these rogue molecules called free radicals. You can think of them like tiny wrecking balls, just smashing your light-sensitive cells to pieces.
And here is the part that is just absolutely terrifying. You don't feel it at all. Your retina has 0 pain receptors, so you can be literally burning a hole in your vision, destroying your photoreceptor cells, and you will have no idea it's even happening until hours or even days later. And by then, the damage is already done.
This is why it is so critical that you only use certified protection. You need to look for this number, ISO 12312-2. That's not just a suggestion, it's the international safety standard. It guarantees that the filter is blocking not just the intense bright light, but also the invisible and just as dangerous ultraviolet and infrared radiation. So let's be crystal clear here. The only safe ways to look directly at the sun are with certified eclipse glasses or a shade 14 Walder's glass. You can also make a simple pinhole projector, which is a great way to view it indirectly and is totally safe. But regular sunglasses? Nope, not even a stack of them. Smoked glass? Exposed camera film? Absolutely not. They might make the sun seem dimmer, but they do nothing to block the invisible radiation that will fry your retina. It is just not worth the risk. Period.
You know, the story of the solar eclipse is really the story of us. It's a journey from pure fear to pure fascination, from superstition to science. We've gone from banging drums to scare away a dragon to chasing a shadow across continents with supercomputers. The eclipse itself hasn't changed, but we have completely. And that really makes you wonder, right? What other mysteries are out there, just waiting for us to stop being afraid and start looking at them with new eyes?